Hello and welcome to our webinar session today on driving the energy transition with BESS. I'm pretty happy to be together with a bunch of practitioners and experts in engineering of energy systems today, as we will try in the next few minutes to touch upon a number of interesting topics and questions like what is the purpose of large-scale BESS and where's the industry heading? So what is the situation in the companies out there? We will discuss major concepts, functions, and methods which can be applied for effective operations and monitoring of BESS systems. And we will have a deeper look into a real case study and an implementation of a large-scale battery storage system in a modern refinery in Europe, in Greece. For the team of presenters today, my name is Stefan Hufnagel. I'm in the energy sales and marketing team here at COPA-DATA HQ in Salzburg in Austria, and I'm together with Luis Williams, our technologist and expert for energy applications. Today we are really happy to welcome our guest speaker, George Avanitis, who joins us today from Athens in Greece. George is a long-term practitioner in energy systems engineering and head of systems integration at the integration company PROTASIS in Greece. A few words about the housekeeping today. We will, during the webinar, we will have around about 50 minutes of presentation, and after that we will have a live Q&A session. So whenever you have any questions, use the webinar tool on your end and type in and submit your questions. We will later on pick them and try to answer them during the live Q&A. The session is recorded, and you will later tomorrow or later actually receive a web link with a collection of all media and supportive information around this webinar. So you will have the recording, and also we will collect the questions which we were not able to answer during the live Q&A session, follow up on them and provide you some of the answers also via this summary page. So for a short introduction or a warm-up around the topic of large-scale battery energy storage, what is the current state of play actually? So let's have a look into some of the industry challenges and the drivers in the energy industry in the next couple of years. So first of all, there's a technological challenge. So due to the increased usage and increased implementation of renewable generation, the grids are challenged in the end. So there is more volatile sources of energy, and in total also due to electrification trends, the amount of energy which is required rises, and this brings the grid into its limits. That's why certain means of stabilizing the grid and supporting the grid and trying to establish a proper power quality in the end need to be taken. And finally, there's a certain desire for self-sufficiency on the consumer side. Moreover, there's an inherent entrepreneurial challenge. So how do you ensure that you make most efficient use of your assets like substations, like solar PV, like power lines? How do you gain optimum capital expenditure and operational expenditure? How do you deal with the technical volatility, as mentioned before, for example, due to renewable generation, but also on the other hand side, how do you deal with commercial volatility as energy prices in some regions are quite unstable at the moment? So it's about thinking about proper investments, setting up proper programs in order to invent new forms of energy usage and more effective use in the end of energy. And finally, there's also a socio-economic trend or a socio-economic shift. There's definitely a shift towards more climate consciousness. On the other hand side, the skills and the experience which is required in order to engineer, to design and to operate energy systems are getting more and more demanding. So in order to cope with that, we need to come up with new concepts and with modern technology in order to cope with this complexity and deal with these complex systems. So for us here at COPA-DATA, there's a bunch of different energy systems we're dealing with, like substations, like renewable generators, solar PV, wind farms, and so on, grid control in general. And large-scale battery energy storage is now one of the new components we have seen growing and getting more and more in the recent years. So what is actually the purpose, or what can large-scale battery energy storage be used for? In a very, very rough approach, I'm dividing it here into 3 sectors. On the left-hand side, you see the electricity transmission and distribution sector, where large-scale battery energy storage is mostly used for grid stabilization, to provide frequency support, frequency regulation, trying to balance demand and response, as battery energy storage systems are able to pretty fast provide energy into the grid or take energy from the grid, and thus they are well suited in order to support the grid in that way, to do frequency regulation, balance response kinds of things on the utility side. And then we have the large-scale renewable generation, as I've mentioned before, large-scale SCADA, wind farms, and so on. And here we have quite naturally a volatility. So the generation capacity, or the generation volume, varies quite a bit over time. And here, large-scale battery energy storage can be used to, let's say, store excess energy in periods where you have actually excess generation, or to supply and close the gap in periods where there is a lack of generation. So capacity firming, shifting the generation volumes is a topic here, where a large-scale battery storage system can help to improve the efficiency of the overall systems. And last but not least, in the industrial and commercial sector, so if we think about manufacturing, if we think about refineries, process industry, or public sector applications, large-scale battery storage can help to support microgrid installations, for example, autonomous installations, help to provide backup power, for example, or in general help to increase the resilience of the overall energy supply. So that's it in a very, very rough approach, what the possible usage scenarios of large-scale, utility-scale battery energy storage would be. From another perspective, let's have a look on the developments, on the market developments. So what are the motivators of large-scale battery storage? Is definitely some improvements in the technology, some improvements or lowering the decreasing costs and costs of installation for large-scale BESS systems. There's more and more innovation programs, grid modernization programs, and regional, national incentives and subventions for building large-scale battery storage systems in order to getting into a more sustainable overall grid architecture. However, there's also impediments, some barriers, which still make it kind of complex or difficult to approach BESS applications, which would be still, as we feel it, or as we perceive it, still a high perceived complexity and high costs versus the possible business benefits and the possible business cases when installing and when starting to implement battery storage applications. There's a bit of a lack of standardization as we perceive it on our side, and obviously if we look on some of our customers, there's some outdated regulatory rules sometimes, and the overall market design is maybe not fully ready to have a clear roadmap or a clear road in order to install a battery system and putting it into the right category of generation. So all in all, it's quite a trending topic. Depending on which trend study you look at, there's always a compound annual growth rate of around about 25% can be 20%, can be 30% predicted, forecasted over the next couple of years. What we see through applications, publications, is that there is obviously a shift now from let's say smaller scale applications with a storage capacity of around about 10 megawatt hours, which were heavily used in order to do these grid supportive tasks. And this is shifting towards higher capacities into the region of, let's say, 100 megawatt hours or even bigger. And this opens the door to go into applications where you would supply energy, electrical energy continuously. So to enter into like intraday markets, being able to offer larger energy quantities and setting up business models based on that. And obviously, innovation, research, evolution in battery technologies will still be interesting to follow up, and can, in one or the other points, accelerate the whole process, definitely. So that's it already from my side for a very short introduction into BESS. And now I would like to hand over into a more practical part to Luis, who will give us some additional insights of practical methods and a demonstration of how a BESS operations and monitoring software system may look like. Luis, the channel is yours.
Thank you, Stefan. So before we get into the demo, I'd like to go through some of the key fundamentals which are required before we start talking about how to build and form a BESS application. So some of these you've already heard of. So the data acquisition, we need to gather data from certain types of hardware, for example, in this case in a BESS application. Xenon offers a lot of possibilities in this regard via our comprehensive driver list for various protocols. But then what do we need to do when we have acquired the data? That's where the data management comes into the side of things. So we can retrieve data from the hardware, but then we can also filter it, sort it, also react and validate whether the data is actually valid or coming from the source that it actually is coming from. And then once we've cleaned and sorted this data, then we start to have a look at how can we visualize it so that the operator can have an ease of use of the application. Things like alarmings, alarms, are they clear and concise? Can the operator then make a decision based off of the alarms? And then that's where the control side comes into. So does the operator need to turn something off or acknowledge an alarm in this regard? So here we are on the control side of things. Then once we've gathered the data, the operator can react based off of certain situations. Then they want to, over a certain period of time, calculate and also present the performance of the application. So either via KPIs from the reporting side of things, or to do drill down investigations of certain alarms via analysis, so from trending, for example. But as Stefan mentioned before, it's turbulent times on the grid, and especially for battery applications. When a battery application or battery system is conceived, it might then need to be rapidly extended or over the course of a few months or years extended. So a key thing when it comes to the application is the ease of deployment, so the application engineering methodology, and then how can we maintain such applications? So rapid deployment of not only greenfield BESS applications, but also the maintenance of existing and the extension of the existing applications. On the next slide, we can see our energy landscape, and you can see some of the areas where BESS plays a role in certain domains. So if we take a look at the top right, here we have the utility side based on renewables. So here we're talking about the prevention of curtailment, for example, from our wind parks, from our solar parks. If we go down to the lower right, then we enter the domain of industrial and commercial. Again, here we will find BESS applications. So with a different perspective, the industrial commercial customers are looking for reducing production costs of the component that they're manufacturing. So in this regard, then peak shaving or something could be utilized for BESS in this area. And finally, in the middle, in the utility section, transmission and distribution. BESS is then used for the hardening of the grid and also avoiding congestion of the grid. So then we start to get into the realms of virtual power lines and things of this nature. So BESS is used in an extremely wide variety of applications all across our energy network. And with this, then we can clearly see, okay, we have a BESS application and it needs to be robust enough to interconnect to various other systems, like I mentioned before. So as the on the top right, we saw the generation. It needs to be maybe AC or DC coupled to solar, for example. And also on the distribution and transmission, maybe as standalone entities which have a grid connection. And then again in the industrial portion where it plays a different role. So with battery applications, a lot of diverse roles it needs to fulfill within such applications. So now I'd like to jump into a demo we prepared for this webinar, and here it is. So this demonstration provides an idea of what a BESS application could look like, and also what is required from an operator perspective in order to safely monitor and control a BESS application. So one of the most important aspects we're dealing with batteries is the state of charge of my battery system as a whole. So in the top left, you can see a representation of the state of charge of my system. An operator, if required, would then need to drill down and need additional information on the state of charge. So then they would drill down and take a look at maybe or change the set points for max or min % of charge or discharge, depending on the situation. Also monitor critical information such as the voltages, the currents, and other such things like this, and also parameters for actually starting or stopping or taking the system in its entirety out of commission if so required. So let's jump back to the dashboard. What other information is important to know? In this particular scenario, we have 2 battery banks, which consist of more multiple strings or racks. And in this application, we have simulated a lithium-ion battery system, for example. So when we're talking about lithium-ion, one of the most important criteria or pieces of information to consider is obviously the temperature of the batteries themselves. If we get into a situation where our batteries are too low, then we start to see performance being affected. If they are too hot, for example, then we start to run the danger of thermal runaway, and also before then the BMS actually taking the specific parts of the system out of operation. So we can see here that we have a short summary of the battery bank. We can see that the strings, all 10 of which are connected, so 20 in total. So let's take a quick look at our power flow. In this specific example, we could be in an industrial or commercial environment. So we can see graphically, visually, whether our battery is currently charging or being discharged. So we see here it's currently being charged from a grid connection due to the fact that our AC load is at this point in time quite low. Then we can also see our real-time monitoring of one of our state of charge, and two of a load profile of the battery, one without BESS. So in this particular instance, you can see a demonstration of the effects of peak shaving on this particular installation. Then what is important to know for an operator, in this instance, we can see that our battery consists of two containers, each with our container temperatures and also the status of each particular rack. Again, our containers are being cooled by our HVAC system on the lower right. And here I can see the status of various racks or strings. So if I wanted to contextually enter or retrieve more information about string ID 10 in battery bank 1, for example, then I can bring up the pop-up and I can do so. And here we have, again, important information such as the average module temperature within this rack, most notably the max module temperature, and also which ID this is, module ID this is located within. So then, as an operator, I can then go and retrospectively investigate why this particular module ID is at a higher temperature than the others. But not only on a rack perspective, I can also go deeper still into my individual modules, which are the data's being retrieved from maybe a rack BMS system. And if I have particular interest in string 4 module 5, then again I can open up a detailed view of this particular module. So let's say, for instance, I've done some investigation and I would like to take this particular string out of commission. We can do this by, on the one side, mechanically disconnecting the string, yes, but also from a SCADA or HMI point of view, also disabling it from the battery management system. So we would then send a signal to the BMS, which would then decommission this section of bank 1. So here we can see the represented status on this overview screen. If we then move to the single line, you can see an electrical schematic of the same which we've just saw with our dual containers and our power conversion system, so i.e. our inverter. And this technology we normally use, so this electrical grid topology here, you can see that this is grayed out, so out of commission. We typically use this for substation load flow calculations on the transmission network for certain applications, but it also works within a battery application context. So this gives additional visual feedback to the operator as to the overall status of the battery pack. And then we have the PCS itself, so with various modes and also measured values which we are retrieving directly from either the inverter or possibly through the BMS itself. And as I mentioned before, in these times, batteries can be extended quite rapidly due to their function. So whether an industrial customer needs to add more capacity to the bank, things of this nature, we would need to then change some parameters of the inverter to help cope with either the additional capacity or in various situations. So this can be done via such an application. So here we are accessing the inverter itself. We get some meta information about its current operation and also from the inverter itself, from the data sheet. But then we could also change such set points such as max power outputs, also the ramp rates according to the grid codes if it's connected to the grid, things of this nature. And then we would go into the trending side of things. So if I was interested, coming back to the example I said previously, in various temperatures of modules, for example, we can trend and track the temperatures for each module. If the rack BMS or BMS allows us to, we can even go in to the different information for each cell. So depending on the scale of the battery application, because then obviously the amount of data points will then exponentially increase if we go down to battery cell level. So this was just a short overview of this BESS application and the methods used to quickly and easily give information to an operator so that they can react based off of the current situation. So one last thing from my side is how can I use or take a look at this application? What we do here at COPA-DATA for Xenon is to provide customers with pre-made templates. So if you go onto our website, copadata.com/energy, you can download this very application. It's all simulated with our soft PLC in the background, so it runs on the local machine. And we provide you a template project and also ready-to-use component templates. So the major components of the battery system, such as the individual racks, the modules, and also the PCS, and many other aspects are contained within templates, which we called object-oriented engineering, and then which allows such applications to be easily extendable. So you get a library also of these components, and also out-of-the-box connectivity. So these components are pre-built with a specific protocol. So one of the most widely used could be Modbus in this regard, but these aren't protocol dependent. So these can be interchanged based on the requirements of the application. So that was it from my side. I would like to introduce George Avanitis from the company PROTASIS, who is going to give us a very interesting look into one of their applications that they did not too long ago. And we are very privileged to have him here. I'll just give him control. Yes, and now, George, it's over to you.
Thank you very much, Luis. Good afternoon from me as well. First of all, I would like to thank COPA-DATA for inviting PROTASIS and me to participate in this webinar. Both companies are sharing the same vision for a green and sustainable world, being ready to support the energy transformation through the smart modernization of the electrical networks. We strongly believe that in the near future, the storage sector will change the dynamics in the energy management as well as in the energy market. Before I continue, I would like to say a few words about me. So my name is George Arvanitis, and I am heading the Systems Integration Division of PROTASIS. The division consists by two departments, the Metering and IT Application Department and the SCADA Department. The SCADA Department is responsible for SCADA applications on the energy sector, and it was actively involved on the BESS project that I will describe in the next slides. I have studied electrical and computer engineering at National Technical University of Athens, and I hold a master in science at the field of energy production and management. I joined PROTASIS at 2007 as a SCADA engineer, and I am very happy that I selected PROTASIS along other career opportunities. A few words about PROTASIS. PROTASIS is a power systems engineering and consulting company established in 2002. So we are currently celebrating our 20 years. Our company offers services and solutions for transmission, distribution utilities, power generation companies, and industrial facilities. Our activities have been in more than 20 countries, and we are counting more than 100 customers. We are a private and independent company, not affiliated to any manufacturer. A few words about our relationship with COPA-DATA. The cooperation with COPA-DATA started in 2007. The first project was the power management system of the electrical network of Jordan Petroleum Refinery in Zarqa, Jordan. Since then, numerous projects, I think over 50, are based on Xenon software platform. Some critical milestones are depicted in this slide. So, at 2009, we commissioned the power management system of Zueitina Oil Company located in the Libyan desert. In this project, we have integrated more than 300 IDs in the power management system. The system spreads in 2 concessions. At 2013, we commissioned the substation automation system of extra high voltage substation Megalopolis. This is the biggest extra high voltage substation in Greece. For this project, there is a success story at COPA-DATA as well as at PROTASIS website. At 2017, we became bronze partner of COPA-DATA. And 2019, we upgraded to silver partnership. And now we are working very hard for the gold partnership. 2021 was a year of innovation for us. We commissioned the substation automation systems of the biggest high voltage AC interconnection worldwide. This is the Crete Peloponnese interconnection project. At the same year, we commissioned our first PV SCADA for a 50 megawatt PV installation in Greece. And of course, at the same year, we set into operation the BESS power management system in Motor Oil Refinery that we will present in the next slides. So let's move forward to our success story. But before this, I would like to say some general aspects of the battery storage. So BESS are becoming a trend in the electrical network because they contribute in the increase of renewable energy sources integration. They counterbalance the stochastic nature of fresh units, which is this is very critical according to how we see things. They increase the flexibility of distributed generation units, while at the same time they increase the efficiency of existing electrical networks, whether we're talking about industrial networks, transmission, or distribution systems. Finally, I would like to say that as a general statement, BESS meets a wide range of applications such as hybrid system using RES, microgrids, interconnected and non-interconnected electrical networks, and of course, industrial networks. A few words about the battery technologies. I would like to begin with one of the most dominant one, the lead acid batteries that are characterized by low cost, maturity of technology, and large temperature rates. The next technology is nickel-cadmium batteries that have high power and energy density and are combining high reliability and longer lifetime. Another technology is sodium-sulfur batteries that are mostly used in power quality support and peak saving services because of their fast charge and discharge capability. One technology, of course, that we are all familiar with is lithium-ion batteries, which has high energy density together with long lifetime and are used in a high variety of applications from portable devices up to electrical bicycles. Finally, the flow batteries are offering fast power response during charging and discharging cycles. In any case, the choice of the appropriate battery technology depends on the special characteristics and requirements of its application, as shown in the diagram in the right slide of the site. BESS has several benefits. I would like to point 3 that are the more critical. The power fluctuation smoothing in RES installations, the backup supply, and the black start functionality, which is very critical for industrial complexes. Of course, there are obvious environmental benefits, an aspect that is of a major importance nowadays. In the same context, here is an indicative example of BESS frequency support functionality, where in this graph here, we can see that an increase in the system frequency, which is the red plot here, leads to a decrease of the output power of the BESS, which is the orange. In the left side, we see the necessary user interface for the management of the BESS power plant controller that provides the user all functionalities to operate the system in a functional way. The best power system that the best power management system that we have developed with the Xenon Energy Edition is installed at Motor Oil Corinth Refinery. Here is a photo from the installation. A few words about Motor Oil. Motor Oil is an energy group based in Greece and founded at the 70s. It holds a leading role in the sector of crude oil refining and marketing of petroleum products in Greece, as well as the greater Eastern Mediterranean region, exporting in more than 70 countries and has about 2,500 employees. More specifically, the project included the installation of 1 megawatt, 4 megawatt hours zinc hybrid cathode technology batteries in the direction of energy upgrade of the existing industrial system, greater flexibility at the peak hours, optimization of the demand profile. PROTASIS provided the power management system of the BESS, focusing on the safe integration with the central monitoring and control system, providing coordination and communication with the battery controller in order, among others, to reduce the active power injection to the grid. The basic components of the PMS are depicted on this slide. I think it's better to move to the next slide where the data network architecture diagram is depicted, and I will present you all the major components there. So first of all, the first component is the central control unit. It is a cell action device which performs all the required control processes. It communicates with the INGESYS battery controller. It collects information from the remote peripheral I/O unit, which is located here, and at the same time provides data to the SCADA system. The central control unit algorithms are developed in IC 6-level-31 programming language, thus can be easily integrated into Xenon Logic Engine. The second component is the peripheral I/O unit. It is also a cell action device which collects measurements and statuses of grid interconnection base and provide this information to the central control unit as well as to the SCADA system. The communication network is a redundant fiber optic network and is based on layer 2 managed Ethernet switches. Of course, we have a SCADA server, which is an rugged and industrial computer which hosts the Xenon Energy Edition software. The operators are interacting with the SCADA system via one client with 2 screens located at the control room of the refinery. The utilized communication protocols are Modbus and IC 62850. In this section, we're presenting the main operating modes. The system has actually 3 main operating modes. The manual mode, in which the SCADA system issues active and reactive power set points to the battery controller. The automatic control mode, where the exchange of active power between the refinery and the grid is predetermined and ensuring the reduction of active power injection to the grid. The fixed mode, where the system follows a predefined time schedule of charging and discharging cycles based on the refinery energy needs. In this screenshot is the operating environment of the system for the automatic mode, where the operator sets all the required set points and at the same time is able to monitor the system performance at real time. In the left pane here of the screen, the operator sets the parameters and the set points for the system operation. So actually it manipulates the power plant controller. In the right pane here, are visualized in real time the main parameters of the system, and the operator is able to comprehend at one glance the status of the system. At the same context, here we have the operating console for the manual fixed mode, where the operator configures the required time schedule here, and at the same time, it monitors in real time the system status. In this screenshot, we have the single line diagram of the installation, where the operator is able to identify the status of the system components, like the operating modes, which are here for the batteries, the injected or consumed power here, the energy flow from the batteries. In this context, we are utilizing the automatic line coloring functionality of Xenon software, as well as the command processing module of Xenon for all the controls from the SCADA. The provided real-time trends here are refreshing every 500 milliseconds and are depicting in a very precise and clear way the status of the system. Finally, the performance ratio, a major KPI of the system, is calculated in real time for daily and overall basis. In this slide, a detailed representation of the battery system is depicted. In this screen, the main characteristics of the batteries, such as the state of charge, the DC current, and DC voltage, are shown here, as well as inverter status, temperature measurements. Alarm handling is a major task for complicated systems like this. So we selected to utilize Xenon Alarm Areas functionality. It is the white A buttons that you see here. This feature provides to the operator the ability to understand, localize the problem, so interact in a fast and secure way. In this slide, a screenshot of the overall diagram is displayed. This diagram is actually showing the power exchange between all the major components of the system, starting from the utility up to the battery storage. The operator can easily identify the power flow. Here I would like to mention that the developed SCADA system is equipped not only with the screenshots that I already showed you, but of course with all standard SCADA screens like alarm event list, trends, communication surveillance screens, as well as extended reporting functionalities. We are very keen to say that we developed a complex project like this in a fast manner and without any back and forth in the development, just by utilizing the wizards and the BESS modules of Xenon Energy Edition software. So we strongly recommend and suggest Xenon Energy Edition for BESS applications. We are very proud to say that this project was awarded in the National Energy Mastering Awards. The project won 3 awards, and specifically the Gold Award for the Energy Intelligence software. We are pretty sure that the judging committee considered the friendly and powerful user interface of the BESS PMS that we developed with Xenon Energy. We finally reached the conclusions, where I would like to mention that PROTASIS has successfully installed a power management system for the BESS and achieved, which is very critical, the smooth integration of the BESS to the existing electrical network of the refinery. We developed the system by utilizing Xenon Energy Edition. The system provides a user-friendly and a non-complicated interface for the operators, allowing them to control and monitor in a quick and safe manner a complex system like this. This was a great goal for us. It is critical to mention that the provided system, as from my experience all Xenon installations, is fully expandable and able to integrate additional power sources in the future. Actually, we are going to expand the system and add the photovoltaic installation that is located in the same area. So this was our story that I wanted to share with you. I hope that you found it interesting. I would like to thank you all for your attention, my contact details will be available to you, and I will be more than happy to reply to any of your inquiries or questions. Finally, I would like once more to thank COPA-DATA for the excellent organization of the webinar. So now I think that we have time for Q&A, so I will hand over to the COPA-DATA team. Thank you very much.
Thank you very much, George, for this impressive insight into a practical real-world case study. I think this was really a very impressive demonstration of the different methods, of the different approaches, and of the different views you will have or you have in such an application. So thanks for that. This brings us to the last section of the webinar, actually the live Q&A. And with that, I would like to introduce another colleague of ours, Jürgen Resch, who joins us tonight today from Sweden, actually. And Jürgen has followed up on our questions already in the system, the questions you have submitted. So please keep submitting your questions as we want to discuss them now, or we have the possibility to discuss and answer them right now. So hello, Jürgen. Hello to Sweden. And I'm sure that we have got something in the pipeline.
Hello, everybody. Yes, Stefan, this is true. We have got and received some questions, some interesting questions. The first one I would like to ask Luis. Luis, the question was about did Xenon or COPA-DATA collaborate with any of the inverter manufacturers to connect to these systems? Is there any collaboration with any hardware manufacturers?
So direct collaboration with inverter manufacturers we don't have, but what is available to us is not only the OT protocols which Xenon supports, but also, as we saw in the application, that a lot of the objects within a BESS application support or conform to what's called a SunSpec data model or device model. And this is Modbus based, and the SunSpec Alliance creates such data models in order to negate the need for collaboration in that regard from a hardware perspective or conformance, but they can all adhere to Modbus device models. And if a lot of manufacturers, which they do currently, adhere to these device models, then we have also implemented these into Xenon. And for this is a great opportunity and also a great thing to have. So collaboration in that regard, no, but in other ways, yes.
Thank you very much. George, there was a question, and I think you are the better one to answer this one. It was a very general question, I would say, regarding batteries. There was one question if there are any important brands or manufacturers for batteries in the world. Like, you know, there are some important brands everybody knows when we talk about cars or when we talk about cell phones, but are there any important brands when we talk about batteries?
No, I don't have any. Our experience was with a specific manufacturer located in the United States, so I don't have an answer for this in order to be honest.
Okay, fair enough. That's fine. There was another question for you, George. If somebody is interested in such a BESS SCADA application as a company like Motor Oil, if they're interested, what should they do?
I cannot comprehend, in order to be honest, the question.
Yeah, I would say they should call you.
Of course, I would say that they can contact us in any case, and we can support them. But I think that the first step is to have let's say a feasibility study to understand if this is something that you need or not. This is how I would approach because different needs are in an industrial complex, like the refinery that we installed this, and the main goal was actually not to export active power to the grid, but there is different requirements when you are installing a battery storage near to a photovoltaic installation, in order to have a better, let's say, better approach from the and better price per megawatt hour. So I think it's different approaches.
Okay. Thank you very much. Luis, are there any minimum requirements a battery bank needs to have, or whatever device, and you name it then please, if we want to use the xenon application set that we have seen?
Minimum requirements. Almost all battery management systems will have a method in which to communicate with them. Most predominantly, as mentioned before, an OT protocol, for example, such as Modbus. There are various BMSs on the market which support other protocols, maybe 850 or something like this. But that is basically the only requirement from a Xenon perspective, is to have a OT protocol. And as I mentioned before, Xenon has a huge array of supported protocols. But as soon as we have this, then we can retrieve data and also write data. Writing data obviously depends on which data the BMS allows you to write. So if they're read only or read and write, so for parameters and things like this. But that's the only requirement from our perspective.
So maybe to stay with that topic, maybe a question from to George. I was insinuating in my earlier part in the presentation that there's still a little bit lack. There could be a lack still of standardization. Now, as you have implemented a quite comprehensive application or doing that, what is your perception? Is there a good base of standards when you work with all these different devices, like the inverters on one hand side, there are sensors, there is the battery management systems, and eventually there's the utility communication, which you might need if you have such a big generator or such a big storage infrastructure. You are implementing that. Were there new standards you could build upon, or was it more like you had to arrange a few things which were quite differently, data models, communication, and so on? How would you reflect on that?
Actually, there is, according to my knowledge, there is no standards applicable. So the only applicable standard that I would imagine is the SunSpec for the inverters. So from the other hand, what we need is actually we need a software capable as Xenon, because you need to have different drivers and to be able to manipulate the drivers at the correct way. Because, you know, as you already say, you have a lot of devices, different manufacturers. Some of them are following some typical configurations, some other are following non-typical configurations. So you should be able to freely define in the driver the communication parameters. I would imagine that systems like this, using actually Modbus, as we did, IC62815 for the IDs that are connected to the system, for the medium voltage or the high voltage. And of course, if you have big generation, this is not our case here, but you need the communication with the remote control centers for the transmission or distribution, whatever. This is how I see this.
Okay, so you still have to have this flexibility to combine different types of devices, different communication protocols, different data models.
Yes, and this is very, very critical for applications like this, because are multi-vendor applications. We are not talking about a substation automation system that you have, let's say, I don't know how many 200 IDs in a very big installation, but all of them are from ABB, from Siemens, from Schweitzer, from whatever. Here you are talking about you have one battery controller, you have an inverter, you have some measuring instruments. All of them are for different manufacturers. So the flexibility is very critical.
Okay, thanks for that.
There is another question for Luis. Luis, I know a little bit of the background regarding that question, but that's the reason why I'm asking it to you. Is there any mobile app for small housing PV systems? Can you answer that question?
So Xenon offers, yes, web-based visualization. So this would be possible. So for household PV also, yes. So this application can actually be converted to a browser or run on a tablet or a smartphone. Obviously, based on the size, then obviously normally smartphones or tablet applications don't give you the whole picture, but it might give you a small dashboard with the most critical information, and maybe even allow you to look at alarms and things of this nature. But yes, this is certainly possible.
Great, thank you very much, George. Just a short question regarding the controller that you have implemented. Was this done with custom code?
The power plant controller, yes, it is code that was written by us in 61131, IC 61131, and actually PROTASIS has developed power plant controllers for PV, battery storage, as well as hybrid power plants.
Thank you very much for this one. Yeah, I'm running out of questions. The last one, I think you answered that already in your presentation, but it was part of the questions here. Luis, where can we get the demo application you have shown us?
Yeah, so just visit our website, COPA-DATA.com. There you can enter the energy section /energy. And there you will find not only the BESS application and how to get it, but also solar PV utility or industrial applications, substation applications. There is a whole bunch of applications there which are free. You can take a look at, you can play around with. So the website is the first place to go.
Okay, thank you very much. And maybe there is, yeah, we have 2 minutes left. There is one last question here regarding, I'm not sure if this was a comment to an answer. It is about the time stamping of each variable. Did we talk about that, and do we do that, and how do we do that?
Was this a question to me, or who is this directed at?
I think it's more to George, I would say.
So about the time stamping of the variables, we are utilizing 61850, the IC 61850 protocol between the central control unit and the SCADA system. So of course there is time stamping. The communications with the inverter is through Modbus. So the time stamping is done on the SCADA side. And this is a very good question because it hides something, that Modbus is a polling-based protocol. So time stamping is not actually very precise because it is related to how fast you are polling data. Of course, with Xenon, you have the capability to poll in a very fast manner the devices without having any problems in the computing environment or in the network. So this is what we did actually. We are polling very fast the inverters in order not to make sure that we are not losing any information. Of course, like this, you are stressing the network, but if you engineer the network correctly, there is no problem on the TCP side.
Yeah. Great. And as a substitute for Modbus. If the inverters provided, you could use other protocols like 6150 or 104. I think, Stefan, this is it from the question side, and I hand now fully over to you. Thank you very much.
From questions from the audience, thank you, Jürgen. I would like to round up maybe the discussion with one final question from my side. Regarding the cybersecurity aspects, I'm pretty sure that also cybersecurity was part of your scope, or is your definitely part of scope of work in applications we have seen just now. So roughly in such applications, George, which methods for cybersecurity do you propose? Can you give a short answer on that?
Thank you very much for this question. It's very interesting. In this application, we have just placed an IPS device, an industrial firewall, at the perimeter of the network, in order to be able to interconnect with the corporate network of the refinery and exchange some data with this, mainly for remote engineering access. But of course, this is not the best way. Not the best way. OT networks are normally isolated or non-interconnected with the internet, but even these threads are there. So what I suggest is, first of all, to study very carefully the topology that you are using, to segment the network, and install devices for intrusion detection as well as intrusion prevention. There are specific devices and manufacturers that are able to monitor the industrial protocols, understand the payload, and raise alerts. So this is the approach that.
Okay, thank you, George. I'm sure this is a topic we could spend a few webinars on, so maybe we will think about that.
The question was, maybe we have overheard it, was which protocol or energy protocol did you use at your project at Motor Oil?
We used two protocols. The first is Modbus TCP for the interconnection of the central control unit with the battery system actually, and we used 61850 for the internal communication between the central control unit and the SCADA system. We selected 61850 because we would like to have reporting functionalities and to be able to make sure that we will receive all data in a quick and safe manner.
Okay, thank you very much. And then there was another question. The question was about the fixed control mode by time in day. So how the operator can create a profile of control of different, I think different profiles, for instance, in a holiday, or change the cycle between 1 hour and to maybe half an hour. Is there any options about that?
We have for the moment we have just one table for the scheduling, but we are already discussing with the refinery that we can have multiple profiles based, and I am thinking based on Xenon scheduler. It will be a module that can do the job, or we are thinking to have some ability to load some CSV files, so or Excel files or whatever. So it will be an offline offline modification of the schedule and load it to the system. But currently there is no need like this from the refinery. I think that the next add-on will be the scheduler. This is what I have in mind.
Okay, thank you very much. And then I have a question for Luis. The question was how the punctual measuring of the temperature of the container is related with the temperature of each battery module, in your simulated demo application. So is there any relationship between the two?
So in the demo application, logically in the back end, no, because it's a demonstration. But in the reality, obviously the temperature shown on the containers would be the container temperature, so the room temperature as a whole. And obviously these are these are in a way through physics linked, but then it's also interesting to monitor then from the specific or required to monitor from the specific rack battery management systems, then to get the information of the actual module temperatures. And this is the most critical. So if the air conditioning unit fails, then obviously you're going to see an increase if you maintain normal operation of your battery, an increase in module temperature. So they go hand in hand. So monitoring the container room temperature as a whole, both are extremely critical. So this is how they are linked in the demo. Yeah.
Okay, thank you very much.
I have a question from my side to insert, let's say, a little bit in between. I was thinking about, I've mentioned before at the beginning, this one maybe goes to George, a bit of a lack of standards I've mentioned. Now let's talk about connectivity and communication. George, how do you see that in general? Let's say lack of standardization. You mentioned Modbus. So are there any kinds of data models or standard structures which you can use in order to establish communication with all the different systems? So this is one question. And the second question would be, how did you have any kinds of communications necessities to the public utility which motor oil is connected to, and how did you solve that?
Considering that we have inverters in systems like this, so an applicable standard will be SunSpec for the inverters. The Ingesys system that we are connected to was not following the SunSpec. So I think that one standard that we should consider, like the PVs, is SunSpec. I think that Modbus is pretty standard for applications for inverters, actually for industrial communications, and having in mind that the system that we are describing is installed in an industrial complex where Modbus is dominating, let's say, so it was the applicable, if I can say, protocol. From our experience with substation automation system, of course, the 62850, IC 62850 is the only protocol that you can use nowadays for the integration of the protection relays. I forgot to mention that we have some protection relays. They are integrated in the system. These protection relays are located on the medium voltage switch gear that power supplies the BESS installation. Of course, all this integrated via 62850. Now about the communications with the control center. The refinery is actually communicating centrally with the control center, so there was no need for a separate communication channel. But of course, if there was a need for a separate communication channel, we will utilize IC 6870, which is the dominant one for communication with control center. One last point here, of course, there is a standard, the part of the 62850 standard. It describes actually how you map data from 62850 to 6870. So this is one part that we have to consider in the standardization. But according to my knowledge, there is no standard like the PVs, for example, no IC standard, or like the wind farms.
So in terms of a solution platform, you still need some flexibility to apply different types of protocols and eventually even, let's say, having possibilities to define data models and manipulate the specific behavior of communication protocols from time to time.
We actually need Xenon on this because it has several drivers. Okay, no, this is very critical for an integrator like me. You should have as tools several different drivers and to be able to manipulate the drivers. So if you have a system that does not have, you know, the bunch of drivers that Xenon have and the capabilities that Xenon have to configure the driver, this will make your life very, very tough. You should be able to manipulate the drivers during the day because you see several things. For example, in this project, now I recall, there was different data types in the Modbus for the integer comparing to the real one, example, concerning the most significant bytes. things like this that will make your life tough if your driver is not easy manipulated like Xenon drivers.
Mm-hmm. Okay, thank you.
We still have time for questions, I think. There is another one to you, George. The question was about the technology or manufacturer of the batteries that you were using there. I'm not sure if you are allowed to answer that question.
I would like to know because I don't have discussed something like this with Motor Oil to provide more information about this. The only thing that I can say is are from the United States. This is the only thing that I can say.
Okay, no worries. Then there is another question. Is there the plan to connect to an energy trading platform for this particular project? And maybe this is also a question for Luisa for the entire system. So George, maybe you elaborate first on that one, please.
Yes, currently for this project there is no requirement like this, but in general, when the energy storage is part of a big photovoltaic installation, yes, there are requirements to connect with a superior system with an energy trader. This is a very good question, and we need to consider the type of communications that we will utilize there. Mainly, from my experience, the energy traders are utilizing APIs, are not utilizing standard protocols. So, and this is something that is not standard at all. So we need to consider a mechanism there that will make our life easier. I have faced this problem with PV installations, where they try to find an API to exchange the data. So this is something that needs to be standardized in the near future, not only for the BESS, but in general for the energy traders.
Yeah, absolutely. I agree. Luis, any thoughts from your side, from the product point of view?
Yeah, so not necessarily the direct questions of our trading platforms, but in Xenon, we offer a .NET driver, which can be written to communicate, as George said. There are no standards in this area. So with the .NET driver, we can create our own communication platform to a trading platform. However, they want to send the data in whichever format, MQTT, via REST, or things of this nature. So we've done some applications where we have forecasting, for example, for weather forecasting, predominantly for solar PV. But obviously this goes hand in hand if we're talking about AC or DC coupled BESS with solar PV. And yes, and via this we can retrieve data from, for example, weather reports for next week, for the next couple of days, and consider these then in Xenon to influence then the schedules, in intraday schedules, day ahead, things of this. Yeah, so this would be an option.
Okay, thank you very much, Luis. There is another one for you. Is there any specific requirement to the inverter or the battery management system to be compatible with Xenon Energy Edition?
No, on the one hand, it comes back to what OT protocols the BMS or the inverters support. But Xenon will almost definitely have a driver for this, which supports that specific protocol. On the other hand, as George mentioned before, there are standards in this regard, and the demo actually uses, and the application set which is available from the website is actually built on the SunSpec data models or device models. So everything we saw in the demo, the inverters, all of the advanced parameters, they are all specific SunSpec data models. And also SunSpec, not only they're predominantly for solar PV, but they also have created models for the battery banks, the modules, the cells, and these are also in there, also for the weather station. So this is what we predominantly use, Modbus based, and the data models are then created in Xenon. So these would be options, but if you needed to select hardware for a specific application, then from a Xenon perspective, we are not restricted in any way which hardware you would choose. No.
Okay, thank you. There were plenty of questions regarding cybersecurity, and George, this is directly for you. So, was there any requirement towards cybersecurity in your project?
Very good question. The system is actually isolated, but this is meaningless in the OT cybersecurity, of course. We're utilizing an industrial firewall for data exchange with the interconnection actually with the refinery data network, just to have some internet access for updates to the computers and emergency RDP. But of course, because we are talking about OT network cybersecurity, it's a very big discussion, and the installation of an IPS, a firewall at the perimeter of the system, does not solve the problems. So there was no specific requirements, but we think that systems like this should follow and have IDS components inside them for intrusion detection, not only for intrusion prevention.
Okay. Thank you very much. Stefan, how is the timing currently? Still time for a few questions?
I think we still have time for 1 or 2 questions.
Perfect. Then I go with the next one, also for George. There was the question about if there were any performance issues in the TCP/IP network when you are acquiring from each module or cell so much information like cell voltages and temperatures and so on.
No problem at all, because always in our networks we are utilizing layer 2 managed switches, so we are separating VLANs. So all the traffic is separated, aggregated, prioritized according to the requirements. So there is no problem or bottlenecks on this.
Okay, perfect. And then for Luis, do you or do we plan like developing a library of for controls and interfaces and logics in Xenon to have a better integration for existing BMS?
Yes, we have already an existing library. So we didn't show it in this showcase, but as I mentioned before, the objects which the application utilize and are built off of are actually contained within a library. But we do plan to extend this for other aspects of battery energy storage. The challenge is in certain aspects there is no standardization, but if there isn't any standardization, our philosophy is to make a control or an interface as generic as possible, and then the likes of our customers can then make small adaptations so that it suits a specific situation or device. So yeah, we are in all aspects of our applications, be it solar or battery energy storage, substation. We're always improving our own library, but also let's not forget that we use the same technology as our customers use. So they can also create what we create relatively simply in Xenon. So that's always the option as well. But yes, we're always improving our own library. Yeah.
Okay, perfect. And speaking about own library and the demo project, there was the question if this demo project that you have shown is somewhere downloadable. What's your answer to that?
Yes, certainly. So if you go to the website COPA-DATA.com/energy, you will see not only this application, you will get contained within the package the demo application, which is simulated with our own 61131-3 soft PLC environment. And then you will get a second project, which is an empty template project with the main aspects in and the objects, which are then communicate to the actual hardware when you are on site doing the site commissioning work, things of this nature. So yes, this is all available online, and please feel free to download them and check them out.
Cool. Okay, so I see there are plenty of other questions, and it would really be nice to go on answering them, discussing them with the expert in the room. But unfortunately, we are hitting the end of this webinar session. Thanks again to everybody for participation. Thank you, Jürgen. Thank you, George, especially to PROTASIS for providing your practical insights and samples. As said before, there will be a media collection page sent out which contains the recording, which will contain a link to the demo application we have seen, and furthermore information like the answers for the Q&A. So stay tuned for upcoming content from our side, for webinars and blogs, for example. And for more information, feel free to contact us anytime, or visit our websites at COPA-DATA.com energy or protasis.net.gr. So thanks again to the team of PROTASIS, to the marketing team, to George, Vasilis, for all the very, very nice and cooperative preparation. We really enjoyed this session, and hope to see you again in upcoming webinars. So that's it from our side. Thanks for watching. Thanks for your attention, and enjoy driving the energy transition with BESS. Thank you very much.
Thank you.
Bye-bye.